So your homework for chapter number 3 has a total of 23 questions. This covers a wide array of topics. Your first question, your first two questions are balancing chemical reactions. And I'm going to go ahead and give you one example practice problem. And just you model what you do after something like this. So the question that you're given first is RE plus, just a second. Oh, okay. So the reaction that you're given is RE plus O2 yields Re2O7. And I'm actually not going to solve this problem. I'm going to solve a similar problem. And I will show you that I am going to balance the chemical reaction Re plus Br2 yields Re Br3. Now, compared to the chemical reaction that I showed you a moment ago, there are some pretty distinct differences, one of which is the product that you're forming. This chemical reaction, however, does have, I believe that's rhenium, reacting with Br2, which is a diatomic gas, just like O2 is a diatomic gas. So there's some similarities between these two reactions. At any rate, the way that you're going to balance this chemical reaction is, and I think the easiest way to balance this is not to use that algebraic method, but instead to balance it simply by looking at the individual atoms and coming to a conclusion on how to best match those up. You've got one thing that is rhenium. There's a single rhenium atom on the left-hand side or the reactant side of your problem, and then you've got a single rhenium on the right-hand side or the product side of your reaction. What else do you have? You have bromine, or Br. There's 2 on your reactant side, there's 3 on your product side. Now you can't do anything to manipulate any subscripts or anything like that, but what you can do, what you can manipulate is coefficients or lack thereof. Now, if we have to get an equal number of bromine on each side of the chemical reaction, well, this is pretty simple in that they both will multiply up to be 6. So you're going to aim to get 6 bromine on the same side. So if you put a 3 coefficient in front of Br2, and then you put a 2 coefficient in front of the ReBr3, that's going to give you 6 bromine on the reactants and 6 bromine on the product side. Okay, so I'm going to go ahead and cancel, or I'm going to cross those out just so I don't get confused, but that's effectively what I wanted to balance. Now, whenever we put that 2 coefficient in front of the ReBr3, well, that's obviously going to throw off the number of rhenium on the reactant side, but the convenient thing is that we've got rhenium as a single reactant, or as a single atom on the reactant side, so we can put a 2 in front of that, and now we've got a balanced number of rheniums. So we have a balanced chemical reaction now, where we've got 2 rheniums on each side of the chemical reaction. We've got 6 bromines on the reactant side and 6 bromines on the product side. That's going to wrap up how to balance a simple chemical reaction. Now, the other part of the question, and this first question actually has 3 reactions. Your next one is balancing a hydrocarbon. And the hydrocarbon that I got was C10 H14 plus O2. I'm going to balance something a little bit different, and we'll see where that goes. Okay, so what I'm going to do, let's see, because I don't want to balance the exact same question or exact same reaction. But instead, what I'm going to do is I'm going to balance C4 H10 plus O2 yields CO2 plus H2O. Now, this is an example of a combustion reaction. Our products are going to be CO2 and H2O. Now, for this question, well, it can potentially get a little bit tricky. This is one where I'm going to go ahead and use that algebraic method. So I'm going to put an A in front of C4H10, a B in front of O2, a C in front of CO2, and a D in front of H2O. Now what I'm going to do is look at each one of the atoms on each side of the reaction. I've got carbon. Oh, I should pick a different color than that. Let's go with this magenta. I've got carbon, hydrogen, and oxygen. So those are all of the atoms that I need to balance: carbon, hydrogen, and oxygen. Now, carbon is found in molecule A, and there are 4 of them. So I'm going to put 4A as the first part of my equation. I'm going to say 4A, and again, I don't like that yellow, so I'm going to switch to green. Maybe it'll show up a little bit better. Erase this, so it's not really legible. So 4A. Okay. Now I see no carbons in my next species. My next is O2. So I'm going to set this equal to the only place where I see carbon on my product side, which is in molecule C. And there's only one of them in carbon dioxide. So I'm going to say 4A is equal to C. Next up is hydrogen. I have 10 hydrogen. Those 10 hydrogen are molecule A. So I'm going to say 10A equals, because I don't have any hydrogen in molecule B, 10A is equal to 2D. D is the only molecule that has hydrogen on my product side. So that's 10A equals 2D. Now, next up is going to be molecule B, where I have my oxygen. I've got 2 of them. So I'm going to say 2B, and I'm going to set that equal to, well, the place where I see molecule or oxygen, that is in molecule C. So 2C plus D. So those are all my reactions. So those are all my equations. I need to figure out the values for A, B, C, and D. Now, I know that I have to work with a whole number. All of these values have to be whole numbers. I know that they have to be greater than 0, and they cannot be 0. And so I think the simplest explanation or the simplest response is to say A is equal to 1. A is my first variable that's provided. In addition to that, if I know the value for A, I know the values for C. I also know the value for D. So I'm going to say 4 times 1 is equal to C. So 4A equals C. That means C is equal to 4. Okay, next up, 10 times 1 equals 2D. Okay, 10 times 1 is 10, equals 2D. That means D is equal to 5. Now my last equation, 2B equals 2 times 4 plus 5. 2B equals 2 times 4 is 8 plus 5 is 13. Divide each side by 2. That gives me B is equal to 6.5 or 13 over 2. I like to keep it as that exponent of 13 over 2 because that reminds me, oh yeah, I have to have whole numbers. And if I multiply, and so to get a whole number from 13 halves, I multiply it by 2. And if I do that to one coefficient, I have to do that to all of my coefficients. So to come up with a balanced chemical reaction for all of these different values, A is equal to 2, B is equal to 13, C is equal to 8, and D is equal to 10. And that's a quick and simple way to balance a chemical reaction. I would say that the toughest part is whenever you kind of come up with your values, come back and make sure that you have the correct numbers. So if we were to put, I'm going to erase my coefficients, or my variable coefficients. And I'm going to put 2, 13, 8, and 10. Okay, so how many carbons does this give me on my reactant side? I've got 8, and then I've got 8 on my product side. How many hydrogens on my reactant side? Well, 2 times 10 is 20. And then on the product side, 2 times 10 is 20. Oxygens, I've got 13 O2. That means I've got 26 oxygens. So 26, that's a trickier number to keep track of. And then on my product side, I've got 8 CO2, that's 16 oxygen. And then I got 10 H2O, that's 10 more oxygen. So I'm at 26 oxygen. So that wraps up balancing chemical reactions, or 2 examples for your homework. That's at least 2 questions. All right, have a good